is monitoring Postgres anywhere with OpenTelemetry. A brief introduction about me is that I am a curious full stack developer working at Enterprise DB. Basically, right now I'm working on building a hybrid control plane where we are running Postgres everywhere, like in bare metal. We are also managing and monitoring the cloud service provider Postgres. And my team is basically focused on observability, that is monitoring, collecting all the data, metrics and logs from different Postgres running in different places and collecting it, and then we are visualizing it and setting up alerts. We are going to discuss throughout the slide. Here is the agenda for the same. Like, we are going to discuss what observability is, first of all. Then we are going to discuss how we can monitor PostgreSQL. Later on, followed by what is cloud native PG. If you have heard about Kubernetes, you might have heard about cloud native PG. I will come into that. And of course, we are going to talk about OpenTelemetry, that is monitoring Postgres anywhere with OpenTelemetry, followed by a quick demo if time permits. So, our end goal will be something like this. We are going to monitor the cloud native PG, which is basically running Postgres on Kubernetes. We are going to monitor a Postgres instance which is running on a dedicated server, or we can call it bare metal, or I can showcase during demo in my own system. And we can also monitor certain cloud providers managed offering like AWS, RDS, Azure, GCP and stuff. And we can collect all this data in OpenTelemetry, process it and make a unified overview, observability view for the same. So before proceeding, let's discuss what observability exactly is. Okay, so observability is basically ability to understand the system internal state using the telemetry data. This telemetry data are basically metrics. Like, we can understand metrics as like at 3 o'clock, how many students are there, how many participants are there in this hall. At 4 o'clock, how many participants are there in this hall. So based on that, we have certain metrics at different point of time. So we can understand metrics like that. Proceeding further, we have logs. Like, we have logs like in this context, in the conference context, we can take example as it's a textual record, like the records of when you were present in the your details, registration details and stuff. In terms of system, we have different events and state changes which we can log. In PostgreSQL, we do various kind of logging, which I'm going to go next. And there is something called as traces, which was recently introduced in which was quite popular in the last 5 years. Traces are generally used for distributed systems. In distributed systems, there are microservices where requests flow from one microservice to other microservice. So we can trace that request across the microservice. So that is what traces are. Going further, what is the step one we need to do? We need to make our system observable. For making the system observable, we need to make our code such that it emits metrics, logs, and this telemetry data. Once this data is emitted, we need to capture this data in some kind of observability backends. This observability backends can be anything like, for example, this is the de facto industry standard. We are using Prometheus for monitoring the metrics and storing the metrics data. Basically, we are using FluentBeat or Loki, designed by Grafana Labs, to capture the logs and store the logs and basically querying these logs. There is also a tool called as Jaeger or Grafana Tempo to basically store the traces. And there's another tool named as Grafana, which is quite popular to monitor and visualize the metrics, logs, and nowadays traces as well. So, here, as we are present, we can talk about monitoring PostgreSQL. I'm not going on what PostgreSQL is. Oleg in the keynote already described in detail what Postgres is. So here we are going to monitor the world's most advanced open source relational database. By default, we can configure the Postgres in such a way, or using SQL queries in such a way that we can monitor certain metrics which are very critical. We can monitor the host metrics where our PostgreSQL is running, like we can monitor the resource usages like CPU, storage, or the memory consumption used by the PostgreSQL. We can check for the query performance, like if there is any kind of slow queries, or what's the execution plans or stuff like that. And we can check the connection details, like how many clients are connected to the Postgres database, and how many are idle connections, and so that we can actively check that we are not maxing out on the connection limits. We can check for the database health, like as just before the talk we saw that there was a replication thing for high availability, so we can also check the replication lag, bloating, or the auto vacuum stuff. We can also keep an eye on the failure rates of this metrics. Going further, we have logs as well, where PostgreSQL allows logging, different types of logging, and these are very useful to capture. In case of error logs, we can capture deadlocks. For warning logs, we can have some slow queries, or in case of low resources, we can get some certain warnings. We have connection logs, which is very critical for security purpose, where we can see that which user has connected to that particular database or a database server when, and that is very, very important. And we can have statement logs, where we can basically monitor the PG, we can basically audit all our queries which is running across in our database for security purpose and auditing purpose, and obviously for troubleshooting as well. Okay, going further, like we have this cloud native PG, which is cloud native Postgres. This is a Postgres operator for Kubernetes. This is 100% open source project, which is recognized by CNCF, and it is right now a sandbox project. For those who don't know, CNCF is a project by Linux Foundation to promote the cloud native stuff. We designed this cloud native PG, ensuring that it is Kubernetes native in mind. I hope you might have heard about Kubernetes. It's like widely used across industries by major applications which you might be using, like Netflix and other stuff. When we think about using a database in Kubernetes, we can think of using Postgres as per our requirement. So to manage the Postgres workloads, we generally rely on human operators, but we have a Kubernetes operator here which can auto-manage the stuff natively. It can deploy, scale, or fail over it, and basically it leverages a technology of streaming replication for high availability. Like it is by default having a primary instance, and it can have more than one or two standby replicas for replications to ensure high availability. And we are not using any kind of stateful sets in Kubernetes to ensure that in case of failure, the data is persisted always. So, going ahead as the topic, we need to focus mainly on monitoring the stuff. So, Cloud Native PG by default offers the Prometheus metrics format metrics, and it has certain predefined metrics which can be extended further for like using custom queries and to gain deeper insights in our DB. And we have a native JSON logging feature here, where we are where we output the JSON in output the logs in JSON format, and this can be collected using certain tools, which we are going to see further. Going ahead, so as I showed earlier in our goal slide, we are going to monitor everything. I'm not going to cover the CSP because that's going to be a very wide topic, and so here I'm discussing about the most important part, which is quite popular among observability infrastructure, that is OpenTelemetry. So it is a open source observability framework. The toolkit, this framework is responsible for generating the metrics as well. We can use the certain SDKs to generate metrics. We can collect all these metrics, we can process it and export it using this particular framework. This telemetry data can be metrics, logs and traces, as we all know. It is very important to note that OpenTelemetry is not an observability backend. Reason is that it does not store the data. It simply receives it, processes it, and then simply exports the data. The most important part of OpenTelemetry is that it uses OTLP, which is a standard way, OpenTelemetry protocol, which is a standard way to transport this telemetry data. I am going to talk about the key characteristics. OpenTelemetry is 100% open source. It is vendor neutral, which is very, very important to remember that we are not having any kind of vendor locking when we are using OpenTelemetry to observe our system. For observing our system, it is not limited to PostgreSQL. We can observe any kind of workloads because it is pluggable with, it is tool agnostic because it is pluggable with any kind of backends, and it supports many type of SDKs, different programming language like quite popular ones like Go, Java and stuff. And as I said that it can monitor any kind of infrastructure because it can run anywhere. In the demo I am going to show monitoring the stuff in bare metal and also in the Kubernetes environment. So it can run on Kubernetes, bare metals and virtual machines, etc. So just to summarize the OpenTelemetry working, here's the data pipeline where basically we instrument our application to emit this type of data like metrics, logs and traces, and then we leverage the most important component of OpenTelemetry, that is OTel collector we call it, which basically receives, process and exports to a observability backend. This observability backend can be anything, like there are certain tools which are basically open source like Prometheus, Loki, and there are certain observability backends which are commercial, which provides managed observability service like Datadog, Grafana Cloud, etc. So here is the design or internal, it is a very simplified design of OpenTelemetry collector where we have three core components. First one is the receiver. As the name suggests, it is responsible to receive all the telemetry data across, like we can receive metrics using Prometheus, we can receive log using a file log receiver, which I will come in detail later. And as I mentioned, there is a very important protocol named as OTLP, which we call as OpenTelemetry protocol, which is the de facto which is the open standard of managing telemetry data. Once we receive this data is being sent to a processor. Processors here are very important, like the processor can be used to filter out unwanted metrics. It can be used to add labels, like for example, I am collecting data from Kubernetes environment, and I am also collecting data from bare metal. I can label this data for filtering or seeing the logs of that particular environment. So for that, attributes can be used. Batch processing, as the name suggests, it is used to batch the data, and we can basically use this for network efficiency. And finally, we can export this data to different kinds of observability backends. For example, I can send metrics to Prometheus. There are tools like Cortex, Thanos for scaling Prometheus, so we can send the data to them as well for the metrics. And similarly, we can send our logs to Loki. Or there is a tool named as FluentBit as well, where we can send our logs for further processing. And we can send the logs to OTLP format as well. The important thing here is you can see that we can send the logs to OTLP and receive the log in OTLP, meaning we can connect two collector running. So it's quite pluggable, like a Lego. Okay, so going ahead to the core theme of our slides, which is monitoring Postgres anywhere with OpenTelemetry. So, as I mentioned, these are the three stuffs which are running on different platforms. Cloud Native PG running on Kubernetes, Postgres is running on a dedicated server, virtual machines or bare metal, and there are certain cloud service providers where our Postgres is running. So we can monitor them using OpenTelemetry. We can basically receive all this data in OpenTelemetry, and we can send this data to different stuffs like we can send the data to metrics to Prometheus, and we can send the logs to Grafana Loki. The reason I am taking these examples are these are quite open source tool and quite popular, which is better tested tools. And finally, to achieve unified observability, we can forward this metrics and logs collected to the unified to Grafana for visualization, which I will showcase in the demo. Okay, just a bit of technical, just an overview of certain receivers we can leverage while observing the Postgres. Is one of them is host metrics, where we can leverage host metrics to monitor the CPU usage or the memory storage, disk IOPS and stuff like that, where our Postgres is running, so that we know that we are not running low on resources. We can set up alerts based on this. We can use a PostgreSQL receiver, which can directly collect, we can just simply supply the DSN, by DSN I mean the connection string of Postgres, and it will start monitoring the Postgres database out of the box. We can also leverage Prometheus receiver, which can basically monitor using, which can leverage Postgres exporter from Prometheus. And because earlier OpenTelemetry was not present, so earlier we used to have this Postgres exporter, which basically connects to the Postgres database and sends all the metrics to the Prometheus. And so here we can use the Prometheus receiver to receive all kind of metrics. And finally, we can use file log receiver. File log receiver can basically tail at by tailing means we can basically observe a particular PostgreSQL file and check, transport or export all those logs to this particular receiver. Once we have received these logs, we can rely on processors. Processors here are again very important, where we can use attributes to add, update or delete any custom labels which we want. We can leverage filter, which we can filter labels to save the storage cost. Basically, we can remove some unwanted metrics if we do to save the storage cost. And finally, there is we can use the batch processing to batch the data and send it to the Postgres. There are certain exporters like Prometheus remote write exporters, which can send to Prometheus compatible backends like Prometheus, Loki, Thanos or Cortex. And again, we can use Loki to stream our logs to Grafana Loki, where our logs will be stored. So this is a basic configuration, very basic. I'm not getting into details due to time limitation here. And finally, we have this OTLP exporter, which I discussed earlier, which can send to any OpenTelemetry compatible, so it can send to another collector as well. Here is a classic example of hotel config pipeline, which we can use for Postgres. So if you see here, there are two pipelines. One is dedicated for metrics, where we have receivers related to metrics. We are processing it and sending finally finally exporting it to the Prometheus remote write and OTLP. Finally, we have this logs pipeline, where we are receiving the, as a file log receiver using leveraging file log receivers, and then processing it and sending it to Loki and OTLP and stuff. Once we send this data, we basically would be able to see that in Grafana. I'm going to show that in demo next. So in Grafana, you will be able to see the metrics at one side, and we can correlate that metrics in a particular timeline, and we can select that particular timeline where there is a spike, and we can see the logs. So in this way, we can achieve unified observability here. Okay, time for a quick demo. So here is my demo setup overview. it seems little too many components, but it's quite simple. We have a bare metal, or in my demo, I'm going to use my local Mac where I will be running a Postgres server, and I will be running a hotel collector, which will collect all the metrics and the logs and send it to another another hotel collector, which is running in Kubernetes. For time constraint, we are not monitoring the CSP Postgres, but CSP Postgres can, there are certain receivers for monitoring the CSPs. By CSP, I mean cloud service providers here. And finally, we have this Kubernetes cluster where we can deploy our hotel collector, which is the central hotel collector, which can receive the metrics from different external stuff and send it to Grafana, Loki, and Prometheus, and finally to Grafana. So, I have prepared my environment. Here is a Kubernetes cluster. I am using a tool named as K9s, which is quite popular to access the Kubernetes cluster. It is like I love this tool. So I have deployed this hotel collector. As you can see in the diagram here, this is the hotel collector which is deployed. And I have also deployed the observability stack where I have deployed the Grafana, Loki, and Prometheus. Hope my screen fonts are visible. And finally, I have also deployed the CMPG operator, and also I'm running a cluster named as PgNepal. If you see, I've created a high availability cluster where I'm running 3 instances, out of which one is primary and 2 are standbys, or we can call it replicas. So whatever data I feed in primary will be replicated to the standby, and we are monitoring this thing using hotel. So going back, I can port forward. I am also port forwarding this 4317 port, where basically I am opening a port to the Kubernetes so that my bare metal hotel collector can be able to send this particular metrics to this one. Okay, so here I want to show my Postgres. So this is my Mac system where my PostgreSQL 16 is running, and I am going to monitor it using hotel collector binary, and I am providing a config file. I can showcase you the config file. So in the config file, as you can see, I'm basically providing a connection string to my localhost system where my Postgres instance is running. I'm providing a path to my log, and I'm inserting some attributes, like I'm saying that this is my local Mac metrics. And finally, I'm sending all this data to another port in OTLP, as I showed you in the diagram here, that I'm sending all this data to the OTLP here. And now we are going to see this in Grafana. Similarly, I am sending all the metrics and logs from here to the hotel collector receiver. So, going to see our Grafana dashboard. So, I am port forwarding my Kubernetes Grafana so that I can access the Grafana in my browser here. I think I am running somewhere. Yeah. So, if we open Grafana, it looks something like this. then we can basically use a feature of drill down, where we can see all the metrics available. So as you can see, we have a metrics related to CNPG backends total, and we have metrics related to other stuffs like PG wall archive status. So we have all these metrics. We can see them, but this view only provides the metrics. But we want to see also the logs at that particular time, and I want to see that particular logs for a particular platform. So I can leverage a feature of explore here, where I can select the Prometheus as my metric source. I can, for simplicity, I am using this example where I will be checking for backends total. Backends totals are number of connections to our Postgres database. I can just say that I want to only monitor the cloud native PG for the moment, and I want to see what's the status in last 5 minutes. So I can see that there is only one connection. I can just aggregate it. So I can see in total there is 3 connections in my cloud native PG. I can run a tool named as PG bench to mimic certain connections. So I can simply go inside that particular cluster in PG Nepal, let's say. I can run the PG bench directly. So here I am running a PG bench where I am mimicking at least 10 connections here. This will be running for 100 seconds. So we will be able to see a spike here. Spike in the number of users. So we should be able to see here. See, now the connections is 13. It was 3 earlier because we connected to we mimicked 10 more users connecting to that. So we are able to see here. Now we want to see the logs also for the same time frame. For that, we can use a split function here, where we can see the Loki. I am going to okay, I can go here. I have opened this earlier. So here is the Loki, where I can select exporter, and I want to see all the logs containing CNPG. So, but there are no logs, so I can quickly generate a log. I can run a PsQL. And intentionally I am saying that generate a error log for PgConfNepal'25. So this is a syntax error, so it will be logged by default by Postgres. So if you see, we have this error log. So for example, there is this sync feature where we are linking the metrics view with the logs view, so that we can see that at this particular time frame, what are the logs present, or what are the logs present for, let's say, last 5 minutes. So we can see that these are the logs present, and we can correlate these logs easily here. So this is for CNPG. Similarly, we can also monitor this local MAC. So I can select another matrix named as PostgreSQL backends, which is again monitoring the connections, and we can have this local MAC as the resource ID, and we can search for certain queries which are present, and we will be able to correlate those queries. So for example, I have generated earlier, there was a spike at this particular interval of time, and at that particular interval of time I generated one query, so we can easily see that we can correlate the metrics with the logs, and we can achieve high unified observability here. So here are certain resources which are available. I think the organizer are going to share the slides with you, and these are very important resources related to OpenTelemetry and Cloud Native PG. These are my contact details. I will be available in the gala dinners for further questions in case you have certain queries. Right now, if you have certain